This video is going to show how to use oscilloscope data to create a stimulus source in PSpice. To accurately analyze circuit behavior, it may be necessary to model custom or irregular inputs, such as data from an oscilloscope, and integrate them into the circuit, especially when working on a project with multiple boards. First, we need a CSV file of the desired oscilloscope data. While one is provided in this format for this how-to, typically oscilloscope data is saved in a proprietary format. To use it as a stimulus, it must be converted to a universal format such as CSV. Your oscilloscope manufacturer will typically offer software to perform this conversion. Let's place the stimulus source first. Select Place Component from the menu. The Component Explorer tab opens. Expand PSpice under Categories and select Source, PWL Sources, Voltage Source. A new list of voltage sources appears, showing all available PWL voltage source configurations. Source VPWL FRE forever imports a signal from a file and repeats it forever. VPWL FRE n times repeats a fixed number of times. VPWL RE forever repeats a PWL source defined in the Properties tab forever, and VPWL RE n times repeats the defined signal a fixed number of times. Select VPWL FRE n times, then right-click and select Place. Click to place the source in the schematic, then right-click and select End Mode. With the stimulus source placed, we need to define the piecewise linear source function. We will load this from our scope data. Double-click the file on the source to change the input file length. The Display Properties window opens with space to edit the file path. Enter ../../serialdata.csv. Click OK to assign the file path. We also need to specify scaling and a number of repeats. Double-click the source to open the Property Editor tab. Locate the cell for repeat value and enter 2. The stimulus will be repeated twice. In the time scale factor cell, notated as TSF, enter 4U to scale all time factor values by 4 microseconds. The value scale factor cell is also available to scale the output of the stimulus. If no value is specified, the scale factor defaults to 1. Since we only need to set the time scale factor for this design, we can leave this cell blank. Click Apply to save the settings and close the Property Editor tab. With the source configured, let's create and run a simulation profile. Select PSpice New Simulation Profile from the menu. Name the profile and click Create. In this example, we will name ours Stimulus Trans. The Simulation Settings window opens. In the Run To Time field, enter 5 milliseconds for a runtime of 5 milliseconds. Leave the other settings as the defaults and click OK to close the window. To view any simulation results, we need to probe the input and output of the circuit. Select the Voltage Level Marker button from the toolbar. Click to place probes at the VTX, VOUT-N, and VOUT-P nets. Right-click and select End Mode when finished. Finally, we can run the simulation. Select PSpice Run from the menu. The oscilloscope design is shown as the input trace, and a differential signal is generated by the chip in the design. Quickly and easily create a stimulus from oscilloscope data to create a realistic source and spice simulation with PSpice. For more tutorials, visit us at resources.ema-eda.com, and don't forget to like and subscribe to our YouTube channel.